Today on Organic Chemistry Made Easy, we're going to be going over common functional groups. These common functional groups are going to help you out a great deal when it comes to knowing chemical reactions and what happens when you add different reagents with different types of chemicals. So to start off with, we're going to focus on this pink column right here. The first functional group I have here is known as an alkyl halide. Notice the word halide on the second part of it. This means that it contains a halogen. So an X right here simply means a halogen connected to an R group. And if you haven't learned this yet in your class, an R group can pretty much be anything. Chemists use an R to signify the rest of the molecule, basically. So the main part you're going to focus on is this X right here, this halogen connected to something, and that is known as an alkyl halide. The next functional group is an alcohol. An alcohol is an OH group. So if you see an OH group in any molecule, you know instantly that that is an alcohol. And once again, it's attached to an R group, signifying the rest of the molecule. Next, we have an alkene and an alkyne. As you can see, these go together and the names sound very similar, so how are you supposed to memorize it? Well, if you think of it this way, an alkene has a double bond, while an alkyne has a triple bond. So the way I like to think about it is E comes before Y in the alphabet. So you're going to have less bonds in the one that's an alkene and more bonds in the one that's an alkyne. So to keep that straightened out, maybe try to think of the alphabet or some other way to memorize that an alkene has 2 bonds and an alkyne has 3 bonds. And once again, we have R groups coming off this side, basically signifying the rest of the molecule. So next we're going to focus on this purple column right here. So the first two kind of also go together. We have an ether and we have an ester. For the ether molecule, you can see we only have one oxygen. But for the ester molecule, we have a double bonded oxygen and a single oxygen. So when I like to think of this, I like to think that the ester has 2 more oxygens, while the ether only has 1 oxygen. The next functional group that we have is known as a thiol, and this is kind of different than the other ones because the name doesn't seem to go with what is in it. We see a sulfur and we see a hydrogen. So whenever you see an S and an H together, a sulfur attached to a hydrogen, it's a thiol, and this is something that you're just going to have to memorize. There's not really a way, there's no connection that I've made quite yet to memorize that an S and an H is a thiol. So the next one is a sulfide, and this one is super easy to memorize because you have a sulfur in it. You see you have a sulfur attached to 2 R groups on the side, and pretty much on all of these, the R groups are there to basically make sure that the molecule is satisfying the octet rule. An R group can be anything once again, but it basically makes sure that this sulfur atom has 8 electrons. So if you see a sulfur, and there's no hydrogen attached to it, you know it's a sulfide. Next, we're going to focus on this blue section right here. The first 2 molecules are very similar to each other. As you can see, they both contain double bonded oxygens. But the cool part is that the top one is a ketone and the bottom one is an aldehyde. And it's an aldehyde because, do you notice the difference? It contains a hydrogen. And there's something different about a ketone and an aldehyde in the word that will help you memorize this. An aldehyde contains an H. So if you see a double bonded oxygen that has an H, just like the word aldehyde has an H in it, you know that this is an aldehyde and not a ketone. So to review, we have a ketone with a double bonded oxygen, and we have an aldehyde that has a double bonded oxygen and a hydrogen. Next you have a carboxylic acid. And the way to memorize this is it looks an awful lot like something we saw earlier, this ester. As you can see, it has a double bonded oxygen, a single oxygen, but it has a hydrogen instead of an R group. So when you see that hydrogen, hydrogen typically makes things acidic, so you're going to think carboxylic acid. The next one we have is known as an acyl halide. And basically this has a double bonded oxygen, but it has this word halide in it, which means that it contains a halogen, which is what this X is. The next column we're going to focus on is this red column. The first one is an anhydride. An anhydride simply looks like a carboxylic acid, but it has 3 oxygens. So the way to memorize this, the way I like to think about this, is the word anhydride seems super long. So it has three things. It must have a lot going on. So when I think of an anhydride, I just think of an OOO, and I just add double bonds to the side. The next one we have is an amide and an amine. So the difference between an amide and an amine is that the amine contains only a nitrogen attached to 3 R groups, basically just to make sure that the octet rule is satisfied. While amide, in case you can't see this is a double bonded oxygen. So an amide has more going on. It has a double bonded oxygen and a nitrogen. So if you like to think about it this way, like I do, amine contains the letter N, which means it's only going to contain nitrogen. But amide doesn't have the letter N in it at all, so it's going to have a nitrogen and a double bonded oxygen. Thank you for listening to Organic Chemistry Made Easy. Feel free to put comments on the page below, and if you guys have any suggestions for future videos, let me know. Thanks for listening.